Hello and welcome to this episode of SPSS one-on-one series with the Warrior Analytics. Today we look at multinomial logistic regression analysis in SPSS. And for multinomial logistic regression analysis, the one required condition is you have an outcome that is categorical in nature, but the categories are more than two. You have an outcome variable with at least 3 categories and above, and then for those categories, they should not be ordinal. There is no natural order in them. We are using here a data set that has such a variable, car category. If you look at the car category, we have 3 levels, that is economy, standard, and luxury. So such an outcome, a multinomial logistic regression analysis would be appropriate. In this data set, we also have age and age, income, and employment, which are numerical variables, but we also have marital status and retirement status, which are categorical in nature. We want to use these variables, these independent variables, to predict which car category someone can own. So multinomial logistic regression is appropriate here. As usual, we start by checking for assumptions, building our model, and then we do a final check on our model that we've built. For the assumptions, I've already told you the type of outcome that we need should be categorical with at least 3 categories which are not ordinal. Okay? Independence of observations, we wouldn't expect you to have repeated measurements about participants. There should be no collinearity. You should have adequate sample size. You shouldn't have outliers. We have previously checked for these assumptions in our previous episodes on binary logistic regressions, where we checked for each of these in depth. If you've not watched those episodes, I highly recommend that you go and watch those episodes to have a better understanding of how to assess for these assumptions. You can click on the link on top of your screen to go and check on those videos. So let's get started. So we are going to start by building our model. So we assume our data has passed all the assumptions. Next, we build our model, and to build the model, simply click on Analyze, go to Regression, and then select Multinomial Logistic Regression. In this dialog box, we put our dependent variable under the dependent variable box, and then we specify the reference category. When you look at our outcome having 3 levels, we have to specify which of those levels are we going to use as our reference. Okay, so I'm going to select first category, click continue. We have got 2 more boxes here, one for factors and covariates. All categorical variables will be put under factors. The numerical variables under covariates. So in this case, we have marital status and retirement status as factors, so we put them there. And then these 3 variables are covariates, numerical variables. So under model, we leave the default settings. Then under statistics, we are going to check the goodness of fit test. Click continue. Yeah, the rest we shall leave as default settings. Then we click OK. So this is our output. We can see the case processing summary giving us numbers in each category. We can see that we do not have any missing value. For model fitting information, okay, we are interested in a statistically significant variable. It is the one that shows us that this model that has the independent variables is better than a model without any variable, the null model. They are statistically different. This is a better model. Here is the goodness of fit test that shows you that the predicted values are not significantly different from the actual values. So our model is a good fit. Then the pseudo R squared showing us the amount of variation in our outcome or our categories that can be explained by the variables that we put in our model. We are interested in this, the middle value that is telling us that 99.1% of the variation in our outcome is as a result of the predictors that we have in our model. So the bigger the value, the better your model is. Then we look at these likelihood ratio tests. This is the one that shows you which of the variables that you've put into your model for analysis is actually significant. When we look at the p-values here, you can see that household income is statistically significant. So among the variables that we've analyzed, household income is statistically significant. Let us look at the parameter estimates to understand this. Our outcome has got 3 categories, but we can only see 2 categories here. Meaning, one of the categories has been made the reference category. So we are comparing standard to economy, or also we are comparing luxury to economy. And when we look at the significance levels, the p-values, we see that only household income is significant. Okay? Even this, it is the only one which is significant. Consistent to our previous table, where we saw that the only significant variable here. In this table, we are also interested in the exponents of beta, the odds ratios. When you get the exponent of beta, it gives you the odds ratios. Let's start by interpreting this variable, which is numerical in nature, and we have an odds ratio of 21.024. So this one tells you that for every unit increase in household income, the odds of someone choosing standard over or instead of economy increases by 21.024, keeping other factors constant. It is the same thing here, that if we are to interpret this, it means for every unit increase in income, the odds of someone choosing luxury instead of economy increases by 128.077, keeping other factors constant. Then, although these are not significant, but we can see how they are interpreted. For marital status, remember 0 is for unmarried and then 1 is for married. Okay? So if we are to interpret these odds ratios, first of all, if an odds ratio is less than 1, it means less likelihood. If it is above 1, it means more likelihood. So here, so this value is less than 1, so it shows like less likelihood. But to get the actual value by which it reduces, you get 1 minus this value, which gives you 0.295. The odds of participants who are not married choosing standard over economy reduces by 29.5% compared to those who are married, because they are being used here as the reference category. Similar interpretation here. Remember, retired, 0 is not retired and 1 is for retired. So it is telling you that the odds of participants who are not retired opting for the standard category instead of or compared to economy reduces by 90.7% compared to those who are retired. Just a bonus tip here. When you're running a multinomial logistic regression, it is equivalent to running binary logistic regression twice. Here we are running two binary logistic regressions into one. Okay? In the first one, you're running when standard is your outcome compared to economy. If you only had two groups, this is what I'm trying to mean. If I just came to data, selected cases, I'm only interested in those cases where the primary is less than 3. So I'm interested in group 1 and group 2. That's why I'm putting less than 3. I say continue and then filter out the unselected. I say continue. So if you look at my data right now, we are only using those data in either economy or standard. Those in luxury have not been selected. So if I'm to run a binary logistic regression, very fast here, and then I put my categorical variable, my dependent variable here, then I'm putting the rest in the model, and then I specify the categorical ones. Okay, I'm leaving last as the reference category here for the independent variables, yeah, and then I click OK. So I'm interested in having this table close to our previous table. So I'm going to paste here this table so that we look at it. When you see age in years, the odds ratio is 0.993, and when you look at age in years, the odds ratio is 0.993 with a p-value of 0.650, which is the same p-value here. Even if we looked at retired, okay, the p-value is 0.185. If you look at the retired, 0.185, and the odds ratio is 0.093, which is the same value for odds ratios for retired. So running a multinomial regression is similar to running two binary logistic regressions in one. So this is how we can present the results of this analysis that we have just run. Yeah, so you can pause the video and read through. So that is how we can run a multinomial logistic regression analysis in SPSS, how to interpret it, and how to report the results of our findings. So next we look at ordinal logistic regression, where instead of just having 3 categories and above, but our categories are having a natural order in them. So don't forget to like and subscribe to our channel so that you don't miss out any of our episodes when they do come. In case you have any concern, feel free to leave it in the comment section. I'll be glad to respond to it. See you in the next episode.